Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform. Just a minute. Good evening, Swim. Good evening, Swim. So once again, I welcome you all to this session of welding, which is going to be the last session of this entire welding series that we have started. So this is going to be the last session of the welding, and we are going to discuss really lots and lots of good concepts in this session. So stick with me, as well as if you have any doubt, meanwhile you can always and always feel free to ask within the lectures. So good evening, Dipankar. Good evening. After the welding, I have uploaded the code sheet. I think you could see that I would be starting the metal forming. So once again, I welcome you all, my dear friends. Before starting, I would like to give a brief introduction about myself. My name is Vidyapati Kumar, and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of various research papers publication of national and international journal of repute. If you have a keen interest about the research works, feel free to Google about my works and study those things. You can follow me at unacademy.com @v.kesar, where currently I am teaching the full course of strength of material focused for GATE 2021. Good evening, Asis. Good evening. So in this session, we are going to see the laser beam welding as well as the soldering, brazing, and the defects. We are also going to see some of the basic concepts like capillary actions. These things we have heard about it. So how these actions, how these concepts are very much helpful in these soldering and brazing, we are also going to see and build our concept. Before starting, if you haven't downloaded the Unacademy Learning app, download the Unacademy Learning app, because currently I am teaching the free classes here. Here I am giving the free classes of strength of material. Full course is there. So I am on a verge to complete the torsion fully. So you can follow me there, because totally entire syllabus of strength of material is covered in the Unacademy Learning app. And there is another section which is like paid section, that is known as plus subscription. So after paying some amount of money, you will be getting the access of that paid subscription, but this is entirely free. And why exactly you should do it? Because you have the opportunity to see the daily live classes would be there, so you can interact with your educator. If you have any doubt, you can ask with the educator. At the same time, courses are very much structured in nature, chronological in nature. Unlimited access of the course content materials, tests and quizzes you can give, and the PDFs will also be provided. And there is a plus subscription, In this plus subscription, you will be getting covered the 100%. Your syllabus would be covered, so entire syllabus would be covered in the plus subscription. And in this, you will have again the daily live classes would be there, so you can interact with the educator, you can communicate with your educator, as well as the courses are very much structured in nature. Test quizzes you can give, you will be getting the PDF of the course content materials, and the unlimited access of the course content materials are also there. Another thing is the iconic subscription. In this, you will be getting all the benefits of the plus, as well as you will have the choice to choose a personal coach. That coach is liable to help you throughout your preparation of GATE and ESE, will strategize your whatever the plans you are doing, where exactly you are lacking, or what exactly you should be change, what you should do the change, or it is needful to do the changes in your curriculum, in your routine, in your giving the mock test. Everything would be given to you in a personalized way, so that your performance get boosted enough. And these would be like a study tracker will also be there, that will study your that will track your study, where exactly you are lagging behind. Suppose if you are giving the practice test, mock test, so you can discuss with your educator will give you your analysis of your paper, that what exactly you are doing the mistake, where exactly you are committing the mistake, and what should be done to improve your progress. So these things are there. You will be getting a lots and lots of question and answers for the practices. Practice questions would be there, mock test will be there. So you cannot have, you will these things are there set so that you do not have to refer any other course material. So these are the benefits of the iconic subscription. These are the top educators of the Unacademy, as well as for the GATE and ESE, Unacademy has lots and lots of batches. New batches are opening to complete the courses for mechanical, civil, electrical, for almost all the branches. So you can check about it if you want. As well as this is the new price list that has been changed. So for a plus subscription, if you want the plus subscription, then you will be getting like in the, for 1 month it would be around 5,500. For 3 months it is 13,750. For 12 months, if you are in a like in a last year, so you can always go for the 1 month or for a 6 months plan, so that you can have the proper preparations. Or if you are in like in 18 months and 24 months is for the second and third year students, so they can always go for these plans so that the concept will be built. But again, if you are using my code SIRVK, SIRVK, then you will be getting a 10% off, and due to this 10% off, the amount would be getting decreased. Like suppose for a 12 month it would be costing around 27,225. so based upon that, you can always go for these plans. And for that, if you need to contact with me, you can always contact me at the Unacademy app also. You can drop a message to me, as well as whenever you are going for the subscription, use my code SIRVK. So let's start our discussions for the today's session without any wasting any kind of times. Okay, Subham, what I could tell you, Subham, you can, I have already told the Unacademy team to create a playlist, and they have created the playlist. Currently, if you could search it, you will get a metal cutting playlist in which 12 videos are there. And there is another playlist that is so these all playlists, you can search it for manufacturing. So for the manufacturing, this is the first playlist in which metal cutting is there, and in the another playlist you will find casting plus welding. Currently in this playlist 26 videos are there. Okay, so I have already told them to update this playlist, and they have done it. So kindly check it, and surely you will find these things. Surely you will find. Okay, so let's start our discussion. With laser beam welding. So yesterday we have seen the electron beam welding, and we have seen that how the heat affected zone is very much less in the electron beam welding, because like thin penetration is there. So let's talk about the laser beam welding, and let's see how it is different from the electron beam welding, because in electron beam welding we are using the vacuum. Clear? So if you could remember, then in electron beam welding we have been using the vacuum, but in this laser beam welding, what exactly we are using and what's the principle behind it, let us discuss about these things. Okay, so let me start this with topic, that is laser beam welding. It is also known as LBW. And what is a laser? Do you know the laser? So laser is actually light amplification by stimulated emission of radiation. So if you could understand the meaning of laser, full form of laser, then you can always understand what's going on in this laser beam welding. So it is very much important. What happened, Ashish? No, I will teach in metal forming. I will teach like see these things we are going to discuss at the end of the topic, at the end of the our session. So please remind me these things. Okay, so if you want to talk about anything else apart from what exactly I'm teaching now, then please stick with me and ask in the last of like when I will be asking with you if you have any doubt or not, because discontinuity is broken down. I personally do not believe in this kind of hindrances. Okay, so ask with me at the last and I will surely answer you everyone. Okay, so let's see about the laser beam welding. So let us first discuss about its figure, what is happening here, and then we are going to discuss it one by one. Okay, just a minute, let me draw it. So what is happening, so there is a tube. So what is there in the laser beam welding? So the first one is, so this is your laser crystal. Okay, so this is your laser crystal, and on this laser crystal, on this laser crystal, what is happening? A Janan tube is there. So suppose a tube is there like this. So there is a Janan tube which is like this. So there is a tube which is wrapped up on the laser crystal. Fine. So this is the tube. The tube will look like this. Fine. So this is a tube. This tube is known as Janan tube. So let me just what is this? This is a laser crystal. Now this crystal may be of ruby or of NdYAG. What is NdYAG? I am going to tell you also. So basically these things, let us assume this to be a laser crystal. Now what is this? This is your xenon flash tube. And this xenon flash tube is connected with a capacitor. Okay, it is connected with a capacitor. And this capacitor is also connected with the power supply. Okay, so there is a power supply. Let me write like that. It is connected with the power supply. Okay, so this is how the arrangement is there. Fine. Now understand, so there is a laser crystal. On this laser crystal, a xenon flash tube is wrapped up, and this is given the power supply by the capacitor. So there is a capacitor by which it is connected, and this connected is given the power supply. Fine. This capacitor is given the external power supply. Fine. So whatever the power supply we are giving to this capacitor is going to store that energy, and whenever there is needed, it will like release all the energy at a time. So that's why we are using the capacitor. It's a difference between capacitor and a normal power supply. So that's why we are using a capacitor. Now understand. Now this whole arrangement is kept in a chamber. This whole arrangement is kept in a chamber. Fine. So there is a chamber. So this chamber is known as optical cavity. Okay. So this chamber is known as optical cavity. Please understand carefully, and when I will be asking with you, that if you have any kind of doubt, you can feel free to ask with me, and I will happy to explain everything. But as of now, understand. So this box is optical cavity, and what is happening, that this part of the box is totally 100% reflecting surface. So sometimes we also use the mirror. So this is 100% reflecting surface, and this surface is partially reflecting surface. Now understand what is happening. Now I am teaching you what's happening in here. So basically what is happening from these arrangement, xenon flash tube is there. From xenon flash tube we are connecting the capacitor, so this capacitor is releasing some amount of energy. So whenever the energy is released, so this xenon tube will what, it will excite this laser crystal. It will excite this laser crystal, and what happens, this laser crystal will release a light ray that is known as laser. As of now, understand it, how it is laser is producing, I will explain it. But understand that laser rays are producing from here. So what is the laser ray? So laser rays will be produced like here, like this. So like this laser rays will be produced. Fine. Understand that there are some of the techniques, there are some of the processes due to which these lights are forming. How these lights are forming, I will explain it. So light is forming, and these are the laser light. These are the laser. Now these lasers are like this. Now these lasers are focused. These lasers are focused like this. So there is a focusing lens. There is a focusing lens. What is this? This is your focusing lens. So this is your focusing lens, and in this focusing lens, so suppose this is your workpiece. Okay, so suppose this is the workpiece that you want to weld. Fine. So what is happening here? That they will converge to a single point due to this focusing lens. Fine. They will converge to a single point. Now you can always think about a scenario in which what is happening. You can always think about a scenario what is happening. Suppose you have a focusing lens, and what you do, you took a paper. Suppose if you took a paper and you use the focusing lens to focus the sun rays, whatever the sun rays that is coming, you just put in the focusing lens. You just take a focusing lens. It is also known as magnifying lens. So that focusing lens or the magnifying lens, what does it do? So whatever the sun rays that is coming, it will focus on the paper. And in the childhood we used to do it, we used to burn the paper with that focusing lens. Right or wrong? Do you remember that sun, सूरज का किरणें आ रही थी. तो सूरज की किरणें को मैं क्या कर रहा था, उन किरणों को मैंने फोकसिंग लेंस को लेकर के उसको फोकस करा लिया और पेपर को जला दिया. तो इन तरह का चीजों को हमने पहले देखा है. दिस इज द सेम कॉन्सेप्ट व्हाट वी आर गोइंग टू अप्लाई हियर माय डियर फ्रेंड्स, दैट समहाउ द लेजर इज बीइंग प्रोड्यूस्ड एंड दैट लेजर रेज आर फोकस्ड from this focusing lens, and understand that this is a workpiece. So in this workpiece, what is happening? A fine welding is formed like this. Clear? So fine welding is formed like this. Why? Because all the rays, all the laser lights are getting focused at a single point. And if a light is going focused at a single point, what is happening? These lights are having the energy. These lights are having the energy, and hence the concentration of the heat energy at this point is getting maximum, and hence the welding is done. So I'm pretty much sure that you have understood these things, and let me explain these things in a great details. Yes, this is a detailed course of manufacturing. I have told you a lot of time, Dheeraj, don't worry. Even if it is a crash course, so meaning of the crash course is that I am teaching in a very fast, in a very limited time. I'm going to complete the whole of the courses, so don't worry about these things. Fine. Okay, now understand. So now understand this. Now I am explaining everything. Understand it. So what is a laser? So laser is nothing but light amplification by stimulated emission of radiation. So before that, let me explain you. Whenever the laser beam, so these laser beam is defined is a welding process. So whenever the welding process is due to these laser beam, the coalescence is produced at the workpiece, right? So there is these coherent lights are impinging upon the surface to be jointed, and hence this is known as laser beam welding. So understand the meaning of the laser. Okay, so just take me the another slide and understand the meaning of laser, then I will explain everything. See, what is a laser? What is a laser? So laser full form is light amplification. L, light, A, amplification by stimulated. Even if you all are engineers, but I'm pretty much sure that most of you have forgotten the full form of laser. But this laser building beam welding concept is hidden in this laser definition. If you could understand it, you can understand everything. Emission of radiation. Now what is happening? Understand this full form. See, so so there is a J&N tube. You have seen that there is a J&N tube. Fine, just a minute. So there is a J&N tube. So these J&N tube will what do? So whenever you are giving the heat to this J&N tube, whenever you are giving the like energy, electrical energies are given. Fine. See, from the capacitor you are giving what? You are giving the crystal. So flash tube, see, flash tube is winded on the crystal. So this is the crystal. So flash tube is winded on the crystal and it converts the electrical energy. See, from the capacitor you are giving the electrical energy. So from the capacitor you are giving the electrical energy, and this electrical energy is converted into the light energy. How this is converted? Have you ever thought about it, how it is converted? See how it is converted. Suppose this is the ground state. Fine. And this is the high energy state. Suppose this is the high energy state. Now when you are giving, so when you have connected a xenon tube with the capacitor, so at a time this capacitor is giving the power supply. Now what is happening? Due to this, since the xenon tube is winded on the laser crystal, so the atoms of these laser crystal will be pumped into the high energy level. So what is happening? Suppose the atom is here. Understand, suppose the atom is here, so it is pumped to the high energy state. So earlier the atom was on the ground state, or we can say that it is at a stable state. So earlier atom was at a stable state. Now when I'm connecting this xenon tube with this crystal arrangement, and when I'm giving the capacitor, when I'm giving the power supply with this capacitor, this atom present at this liquid, at this like crystal, that laser crystal is getting excited and it is reaching to the high energy state. Now what is happening meanwhile at? See, so atoms will release. So suppose this is the intermediate. Let us consider a intermediate energy state. So atom is at here. Now if I want, see, this is an unstable state. राइट और रॉन्ग? बिकॉज सी, अगर मैं सपोज करें कि आपका स्टेबल और अनस्टेबल को समझने का एक तरीका है. सपोज करें कि आप 5 रोटी खाते हैं. अगर मैं आपको 10 रोटी दे दूं तो डेफिनेटली खुश तो आप हो जाओगे, मुझे खाना ज्यादा मिल रहा है. बट अंडरस्टैंड, क्या 10 रोटी आपका स्टेबिलिटी है? क्या आप कंफर्टेबल फील करेंगे? नहीं फील करेंगे ना. इसलिए always like this also you can understand that atoms also do not want to go into unstable state. They always have a tendency to come back to the stable state. Now see what is happening whenever they are coming back to the stable state. Suppose that if you are giving like any kind of photons, or you are giving, suppose that they are coming to the intermediate, and from the intermediate again they are coming to it to the ground state. So they want to come, say they want to come into the ground state, that is a stable state. And when they are coming, they are liberating the photons. They are liberating the photons. They are liberating the photons. And photons are which nature? They are of monochromatic. They are of monochromatic nature. What is the meaning of monochromatic, my dear friends? Whichever the light rays, suppose if light rays is having a single wavelength, if wavelength will be single, definitely frequency corresponding to that wavelength will be also single. So monochromatic light is such a type of light in which we are having a single wavelength light rays, and that rays is this, my dear friend. This is what is the rays. This is what is the rays that is coming out from this chamber. And see, this part is 100% reflecting surface. So whatever the light rays, whatever the photons that is being whatever the photons is being produced here, these photons will, even if they want to go to here, they will be getting reflected back to this surface, because this is the total 100% reflecting surface. Now from this surface is the partially reflecting surface. So definitely some of the photons in form of light energy that will come outside, and when they will be coming outside, we are using a focusing lens, and with the help of that focusing lens we are focusing it on the workpiece, and hence we are getting a welding. Have you understood this concept of laser beam welding or no? Just give me a thumbs up so that I can understand that you have understood this welding technique, and then I will give you some kind of notes, and definitely we are going to proceed next. Harshdeep Chauhan ji, definitely it is going to be very, very much helpful for the production engineering students also. Definitely. I'm pretty much sure if you have watched my videos, then definitely you will be able to solve almost all the questions of previous year papers and for different papers in your PI branch. Isn't it? So now understand. So what is happening here? Let me explain it. So the atoms will be pumped into high energy state or high energy levels, and atoms will release in the form of photons using Zenon tube. Okay, so see, you have seen that these photons are liberated. See, these photons are liberated from the Zenon tube. Fine. तो यही तो फोटोन है, ये फोटोन क्या होता है? Red fluorescent light होता है, and that red fluorescent light is actually termed as, my dear friend, laser. Clear? So this is what is there. Now what is happening next? Now from the reflecting surface or from the reflecting chamber, monochromatic and coherent light rays will be coming, and or coherent light rays are coming, and they are focused or converged on the workpiece at a given point. By what? By focusing lens. Now see, when they are getting focused at a single point, see here. So when they are focused at a single point like this, right? So what is happening? So here this will be focused on the workpiece at a given point, and due to this, heat concentration will be maximum, and heat concentration will be maximum, then what? Thickness, high thickness would be there. So let me write these things. So due to this, heat concentration will be maximum, and hence high thickness and high melting point metals can be welded, because there is a huge amount of energy that is produced there, so we can always go for the high melting point materials that can be welded from this. And see, my dear friend, since these beams, these rays are very much focused, so what I can say, heat affected zone will be minimum. So yesterday I have shown you that in TIG welding, in MIG welding, in plasma arc welding, in like electron beam welding, in laser beam welding, what is the weld area that they are covering? So in that figure, if you could remember, then in that figure I had shown that electron beam welding has a very good focusing and the weld is very much less. Okay. Now from here, so this is what is all about this thing. And see, one more thing that we have seen, if we are comparing with the electron beam welding, that there is no need of vacuum. Okay, so there is no need of vacuum in this process. And this is all about the laser beam welding. Now where exactly we are using it? So if you talk about the application point of view, then definitely welding of aluminum, copper, titanium and other super alloys in aerospace and electronic industries. See, tomorrow in yesterday's class also I have told you about the electron beam welding. So if you could closely see the applications of these two things are closely used for a very precision welding. Fine, very precision welding. And from the electron beam welding, laser beam welding is a little bit cheaper, so we are using these also as a replacement of electron beam welding. Where we cannot afford it, definitely that industry go for the laser beam welding. But even if we want a very high precision in cryogenic industries, in like nuclear power plant, definitely we are going for the electron beam welding. In ISROs, like in DRDO, for these kind of things, we are definitely going for the electron beam welding. So if you could remember those things, so definitely those things are very much good. So before going into it, I also want to give some more definitions. So see, this is the depth. Suppose this is the depth of the depth of the sheet metal, and suppose this is the B, breadth. So in yesterday's class I have told you about the D is to B ratio, what is forming in the electron beam welding. So here in this case, the D is to B ratio is 4:1 to 10:1. Okay, and the velocity of welding is about 10 meter per minute. Same velocity in the case of electron beam welding also was 10 meter per minute, and in this case also 10 meter per minute. So these are the things that we can use. And see, my dear friend, we can also use, like I have told you here that in laser crystal we are using the ruby. So what we can do it, how we can produce the laser? So either you can produce the laser by using the CO2 laser or by using the Nd:YAG. By using the CO2 laser, I'm not going to great details in these because these things are not very much important from a GATE point of view, but understand that we can get the laser from this CO2 laser also, and from Nd:YAG. Nd:YAG. What is this Nd? So basically this Nd is neodymium So it is neodymium YAG. What is the YAG? So it is, for Y it is yttrium, for A it is aluminum, and for G it is garnet. So what is exactly, so when we are, so suppose you have these thing YAG, so what you are doing, you are doping these YAG with neodymium. So this is what this is, this is neodymium doped yttrium aluminum garnet, and this is all about the NdYAG. So this is the NdYAG. So this, from these ways we can generate the laser. So I hope these all things are clear to you. Once more, sir. Okay, could you now tell me that is it required to repeat, or is it fine now? Because I have explained it in a great way. So if you want me to explain it, then just tell me very fast. Just tell me very fast so that I can explain it. Is it a need to explain, or is it okay now? Tell me very fastly. Tell me very fastly, because we are going to cover a lot of thing in this session. Understand. So this is like a laser crystal is there. In this laser crystal we are winding up the xenon flash tube. Xenon flash tube is there. So this is the xenon flash tube. This xenon flash tube is connected with the capacitor. And why we are using this capacitor too? Because see, अगर मैं पावर सप्लाई से मांगता हूं भैया पावर, मुझे पावर दे दे, वो धीरे धीरे करके पावर देगा. लेकिन अगर मैं कैपेसिटर से मांगता हूं पावर कि भैया कैपेसिटर मुझे पावर दे, वो एक बार में ही बहुत सारा पावर दे देगा. एंड हेंस दिस इज अ रीजन, दिस इज द की रीजन व्हाई वी आर यूजिंग द कैपेसिटर, बिकॉज when we are connecting this xenon tube with this capacitor, very huge amount of electrical energy is given to this xenon tube. And what this xenon tube is doing, the xenon tube is like it is wounded on this laser crystal. So due to this, what is happening, the atoms at the ground state will get excited and go into the high energy state, and where they are very unstable, very uncomfortable, and they want to get into the stable state. And whenever they are going into the stable state, they will release a packet of energies. That packet of energy is known as photons, and these photons are very much monochromatic in nature. So monochromatic light is emitted from here, and hence we are getting this laser, my dear friend. And hence this laser is being focused by using this focusing lens. We are using this laser and we are using this focusing lens to focus it, and when it will be focused on the workpiece, a very fine clean weld we are getting it. Any doubt till now? Yes, I have explained, Asis. I have explained the function of capacitor and diagrams also. Okay, so now I think that you all have understood everything with a very like understood these things. So let us move towards our next topic. Shall okay, so let us move towards the next topic. Okay, so I'm moving towards the next topic, and that topic is brazing and soldering. Okay, that is also a very good topic. So this is solid or liquid state welding state is there. So we are using the soldering and the brazing. So let us understand the soldering and brazing one by one. Suppose this is what, this is a workpiece, and you want to weld these workpiece. Okay, so suppose if you have kept a very less distance, between these two workpiece. So in the brazing and in the soldering, what we are doing it, we are just inserting the metals in these cavity. We are inserting the metals in this cavity. So see, in this case, what will happen, less metals will be there. Now if I would separate them with some distance like this, when I will do the when then I will do the brazing, then what will happen? Then see, then more amount of metal will get deposited here. So what we can say here, more metal is there, more metal is there. Now if I would separate it with a very huge difference, very huge difference, and then when I will do the welding, see, either welding will be inappropriate, or we are not getting a very good weld, now if you could see from this figure, you can very much understand. Can you tell me if this is A, B and C, so in which figure strength is more, strength of the joint will be more in which figure, A, B, C? I want a quick reply from you all, my dear friends. Can you tell me in which of the figure A, B and C, in which figure my strength of the welding would be highest? Can you tell me? So this is the gap, fine. So if gap was like very less distance, or gap little bit more gap, and very high gap is there, so what you can understand, A. Okay. Now see, understand what is happening here, my dear friend. See, here in this case we are having a lot of metal deposited here, fine. So more metal is deposited, and here less metal is deposited. So what is happening, suppose if you are giving a very not very big gap like this, but you are giving a very good gap, that is optimum gap, then we are getting a very good amount of weld. So what I'm trying to say you, if I would be plotting a gap and a strength, what we can understand, that the strength of these kind of welding would be more. Why more? Because metal is deposited in a very good quantity, and see, gap is not very big or gap is not very less, it is good, it is an optimum gap. And for this kind of gap, what we can say, that if my gap is very low, see here, if my gap is very low, so suppose if my gap is very low like this, if my gap is very low, then definitely strength would be less. Again, if my gap is little bit more, then strength will increase. Again, if my gap will be more, then definitely strength will be increased. Again, if my gap will be very much more, again strength will be increased, and you will get a curve like this. Now understand, there is a certain optimum gap, beyond which if you would increase, then you will decrease the strength, like this. In this case, strength is less, so you have given the gap more than this, so it is in this region. So C is lying in this region, and if we talk about this, so A is lying in this region, and somewhat like this, B is lying in this region. Have you understood this concept? Have you understood this graph between a strength and a gap? See what happens if there is overlap case. See, basically we are talking about the gap, in overlapping also. See, in the overlapping also, if we give, see, suppose, think about, if you could think in yourself, definitely you can have the answer. Suppose if you have overlap like this, okay, suppose if you have overlap like this. Now understand, this is also overlap. Now if you will do the welding, see, overlap is not properly, it is like overlap, but the distance is very less. Now if I would overlap like this, suppose like this, if I would do a lap joint like this, definitely the strength will be more of this compared to this. So definitely we can understand the gap should be always and always optimum, and the graph would remain true for each and every cases. Understand or not? Okay, so let's move towards the brazing and soldering concept, because this concept is important for this point of view. Okay, now understand what is a brazing. So this is a brazing process. So this is a brazing process. So what is this brazing process? So in this brazing process we are using a welding torch. Okay, so there is a welding torch, and this is a job. Suppose this is a job, suppose this is a plate 1, this is the 2, and you want to weld these two things with help of a brazing. So process is same. What is the difference in here? Difference is this filler material. So what exactly is this? Basically the filler material that we are using it to weld this thing is having the temperature greater than 427 degrees Celsius. So this filler material or the filler metal has the melting temperature greater than 427 degrees Celsius and less than the base metal. So this is the first property of the filler metal in the brazing. So let's analyze these things. So in the brazing we are talking about the filler materials. Okay, so in the brazing what is happening? The filler material, so the melting filler material, just a minute, melting point or melting temperature of filler material is greater than 427 degrees Celsius and less than melting temperature of base metal. So first thing that you have to always keep in your mind, metal or material, whatever is there, don't get confused in that. Now what is the second property? So see, this filler material is not of like anything you can use the filler material. In this filler material we are using a specific composition, and what is it? Understand. So this filler material is an alloy of copper, that is Cu, and zinc, that is Zn. So it can be alloy of copper and zinc and silver, that is Ag. So you can use these things, or you can also use aluminum, that is Al. So you can use these things of alloy as a filler material. Fine, as a filler material. Now this filler material is known by a name. This filler material has a name. What is the name? Its name is spelter. Now let me tell you, see, in the soldering we use a filler material in the soldering operation. We use a filler material. What is the name of that? Can we say that solder kahan hai bhai, solder leke aao? So we say that filler material, the name is solder. So similarly in the brazing, the filler material used here is known as spelter. Clear? Is known as spelter. Okay, now understand, we use the another thing. See here, till now in the throughout analysis of the welding we have understood the significance of the flux. कि भैया फ्लक्स मटेरियल की कितनी ज्यादा जरूरत है हमें वेल्डिंग करने के वक्त. Why flux is needed? Because flux material actually restricts to form the oxides, and whenever the oxide formation will not be there, definitely my weld would be very much good, my weld strength would be high. So here also we are using the flux. My dear friend, and the name of the flux that we are using it, borax. So let me write it here, that flux flux material used is borax. Okay, now what I am going to write here in the brazing, this is the entire most important line throughout this, like in welding, whatever I am telling you, this is the most important line. Please understand it, please understand it. In the brazing, filler metal is entered into the workpiece by means of capillary actions. This is very much important, my dear friend. This is very much important. This is very much important. Capillary action. What is the meaning of capillary action? What is the meaning of the capillary action? Can you tell me what is the meaning of the capillary action? What do you understand by the capillary action? Sir, how is the flame produced, fuel and all? Mihir, that is same, my dear friend Mihir. See, if you have watched my all the videos, definitely you are knowing that we are using some power supply. So definitely we are using some power supply. I'm not showing into that those things because these things are like redundant at this point of time. At this verge, we are in a verge to complete the welding. So definitely I assume that these things are in your mind, that we are using the power supply, and definitely we are using the like these filler material is there from the extra, from the outside we are using the filler material, and from the power supply arc is generated, right? We have seen that how the arc is generated. I have also discussed how arc is generated. So basically you are using the DCRP or the DCSP. So based upon that, arc can be varied. These things are there. So definitely you are using the power supply and arc is formed. So with the arc, heat is generated. With the use of the filler metal, you are just melting this filler material, and hence this filler material is concentrated here. Okay, and hence you are getting the joint. So basically what is the difference throughout there is no difference in the welding process, my dear friend. The difference is here about the filler metal. So this is the difference thing, this is the most important thing, that filler metal has the melting point like this is the most important. Gate questions are asked from here. What is the temperature? Tell me about the temperature. Or the filler material, what is the alloys that we can use? We can use the copper, we can use the zinc, we can use the silver, we can use the aluminum. What is the flux material that we are using? We are using the borax. And most important thing, what is the principle behind the brazing operation? That is the capillary action. Okay, so tell me what do you know about the capillary action, then I will explain these things. No, Mihir. I think now you got the idea about everything. Okay. Ability of liquid flow. Okay, Asis has told is capillary flow, I guess, sir. Okay. Okay, so very good attempt. Very good attempt. Now understand. Now before going into it, let me tell you about. Okay, understand. Suppose this is a slide and this is the water. Okay, now what is there? What is happening now? Understand. So what is a capillary action? First of all, understand a capillary action. What is the meaning? So see, if you could understand the science behind anything, then definitely you will be like in the love of this manufacturing subject, my dear friend, because this is a very lovable subject. If you could understand this, you would really love it, and definitely you are going to score 18 to 20 marks from this subject also. So understand what is a capillary action. So whenever there is a spontaneous flow of liquid into the narrow tube, into the narrow cavity without any external force, or we can say the gravity, that is known as capillary action. So what we can write here, the spontaneous flow of liquid into narrow tube or you can say a cavity without any external force, or we are not even using the gravity also. Okay, then this is the capillary action. Now understand in this figure, so this is a slide, this is a water. So this water molecules is bonded. So there is a two terms. I don't know how many of you have heard or not, but I'm pretty much sure that you all are engineers and definitely you have heard about the two terms that is known as cohesion and adhesion. And adhesion, you have studied these things in the fluid mechanics. Okay, now see, what is the cohesion and what is the adhesion? Suppose we are having the water molecules like this. Fine, this is the water molecules, like this is a water molecule. Now suppose if you have water molecules, so when this water molecule will be like this, they will be attracted towards each other, they will be bonded, like keep molecules together. So cohesion is a force in which keep molecules together. So here the molecules are together, so this is the cohesion that is acting. Now understand, this water molecule, see, this water molecule is bonded by other water molecules with the cohesion. Fine. Now see, when I am taking this slide and putting it down and touching the surface of the water, what is happening? Understand what is happening. So when I'm touching this surface of the water or ink, then what is happening? Whatever the water and the ink is there, so it will just move upside, and this is what is known as the capillary action. This is a spontaneous flow of a liquid into anything without any external force or gravity. That is known as capillary action. Understand by this also. See, what is this? Is it a water molecule? Yes, it is a water molecule. Now earlier this water molecule is bonded together with the cohesion force, so this water molecule is like bonded like this. Fine. Now what is happening? When you just took a fork or a spoon, whatever, any other thing, you are taking it and you are touching the surface of the water, so what is happening here? This is, earlier was the cohesion was acting. Now what is happening? Due to this adhesion, what is the meaning of adhesion? In the adhesion, break up the molecules and attract to the near surface. So this is basically happening in the adhesion. So these molecules, so earlier cohesion was there, now due to this touching these things, my adhesion force is very much high than the cohesion, and due to this, these water is get stick on these spoon surface, and hence what is happening? This is sticked. तो क्या होता है? इफ यू कुड रिमेंबर, तो हमारा जो स्पून होता है ना, स्पून भीग जाता है, स्पून गेट वेट, and the same principle is happening in case of brazing also, my dear friend. How it is happening? Understand from this figure. Suppose this is a plate, or a pipe. Suppose this is a pipe. Okay, so I'm showing a cross section view. Suppose these are the pipes, and you want to join it, now you can understand that before joining, you can understand that here, what is this? Is it flux? Just let me change the color. What is this? Is it oxide layer? So see, oxide layer is on the surfaces of the pipe, so we cannot join it, and hence we require the flux. What will the use of the flux? This flux are like, basically it has some acidic things in that. What is happening? The oxide layer is just removed clearly like this. Suppose what you are doing it, you are just giving the flux, and due to this flux these oxide layer will get removed. Fine. Now see what is happening. What is happening from here? Suppose you are giving the brazing, suppose you are doing the brazing phenomena. Okay, so what you are doing, you are giving the, see in this figure, understand from this figure. So what is in this figure? You have the welding torch, and with the welding torch there is a filler material and it is being put, it is being stick to here, and here the welding process is understanding. So just focus on this area and try to understand here, try to understand here. So what is happening? Metals, whatever the metals that you have understood, that filler metals from here, the filler materials are going inside it, are going inside it. So see, earlier the filler materials was sticked with the cohesion like this, like this, like this, like this. So understand the filler material, this is a filler material. So suppose the earlier the filler material is having what? Is having the cohesion, is having the cohesion. Now this surface, understand this surface with the spoon, with the spoon, this is the spoon case, this is the spoon case, right? This is a spoon case, and this is earlier, this is like cohesion. So what we are good understanding from here, that what is happening, earlier the cohesive force was acting, but as soon as they are reaching to the surfaces of this metal, of this plate, of this pipes which we are welding, what is happening, they are getting sticked, they are getting sticked with the surfaces like this again. So if we are doing the welding, if you are doing the welding, so it will stick like, if you are doing the welding, it will stick like this on the surfaces. Again they will be sticking like this on the surfaces without giving any other force due to this capillary action. This is all about the capillary action. So this is the capillary action by cohesion, by cohesive and adhesive force. You are having the, you are getting the welding, and in this fashion, like this, entire area, entire place is welded by this capillary action. So this is why what I have written here, this is why what I have written here, this is why what I have written here like this. Filler metal is entered into the workpiece by means of the capillary action. So now can you understand the meaning of the capillary actions? Can you understand the meaning of the capillary action? Sir, देखिए एक एक word का meaning होता है sir. Each and every word has some kind of meaning. We cannot throw any words haphazardly. We are engineers, and definitely engineers should think like this way. Definitely, if your concept will be good, then only you can score a very good grades and a very good marks in in examinations, and even if you can ace the interviews also. So can you, are you now like, have you understood the concept of capillary actions or not? Tell me if you have understood it, then just tell me that if you have understood it. Now see what is happening, what is happening, and now understood it. Suppose if anyhow any oxide layer is there, suppose any oxide layer is just there, so you can see these layers are very much fine, but here the oxide layer is there, or we can say that some impurities are there, whatever the things are there, I don't know, but some impurities are there. What is happening in this case? Now if you are doing the brazing or a soldering case, whatever the cases may be, the concept, the principle is going to be the same. So if you are doing the brazing, what is happening, since these materials are there, so here what is happening, here adhesion here adhesion will not happen. Why adhesion will not happen? See in the earlier case, surfaces was very much clean, and hence they were sticking with these filler materials is sticking with the other surface because surface is clean. That's why adhesive force comes into play. But now here the surface is not very clean, and definitely adhesive force will not come into play, and hence we are not getting a good welding, not getting any welding. Okay, so we will not getting a good amount of welding. So you can understand this process by this also. See, suppose if you took a slide, suppose if you are taking a slide and you are just putting a thumb here, just a minute, thumb here, and here. So now if you have a fingerprint on those surfaces, maybe if like a sweat is there or oil present is there, then what is happening? Due to this capillary action, this fluid will travel in each ever area, but not in these area and these area. See, in the earlier case, there was a pure capillary action like this, but in this case these things are there, so that you can properly visualize this case. This is the case that is happening in case of a brazing, in case of a brazing or soldering. Okay, so I'm pretty much sure that you have understood the whole science behind the capillary action, my dear friend. And definitely let's go back to our discussion in which I have left you, like this. So filler metal is entered into the workpiece by means of the capillary action. So you have understood these things. Let me tell you about the applications where we are exactly using these brazing. Okay, so we are using these brazing technique for fabrication of hydraulic circuit to produce leak proof joint. We also use for fabrication of radiator bodies in automobiles, and we are also using it for the plumbing operations. छोटा मोटा plumbing का जो operations होता है ना, plumbing में जो जहाँ पर भी हम use करते हैं, we also use. Now my dear friend, before going into the next topic, I want to ask from you, do you have any doubt till now? Do you have any kind of doubt till now? Always welcome, human being, always welcome. I always try my level best to give you a very good content, because obviously like हम लोग डिग्री लेके तो निकल जाते हैं. We definitely take the BTech degree and come outside of the college, but we definitely not having that kind of knowledge. So my thinking is like that you should also develop your knowledge, and simultaneously you should also crack the GATE examinations and the ESE examination definitely, so that you can also be sitting in any of the reputed place. Fine. So definitely knowledge is very much important, and if you have any doubt throughout it, just let me know before going into the next topic. Okay, so everything is clear, so fine, very good, everything is clear, then very good. Let us talk about the soldering operation. So what is happening in the soldering operation? So we have seen in our local shops also, we have seen n number of times this soldering operation, but the difference we do not know. So there is a soldering iron, and suppose this is an LED, and this is the two parts, two end is there like this, and we want to solder. So if we want to solder like this, what is happening? We are using a external filler material. This is a filler. This is a filler material which is known as solder, and this filler material is used to get a joining, a fabrication here in this case. Fine. So basically this is a copper rod is there in the soldering iron. This is a copper rod which is heated by a power supply. Again the power supply is there, it is heated, and from the heat like filler material is there, so this filler material will melt, and definitely it will form a joint at that point. And again we are using some kind of flux. Have you seen in the electric shop that whenever the electricians are welding, whenever the electricians are performing the soldering operation, they use some kind of wax like of thing, and they say the flux, that it is a flux, like brown color flux are there. Have you seen these things? Brown color wax like चिपचिपा कुछ एक ऐसा चीज होता है, एक छोटे से डब्बे में होता है, दैट थिंग इज नोन एज फ्लक्स माय डियर फ्रेंड, एंड दैट फ्लक्स इज व्हाट, एंड दिस फ्लक्स इज व्हाट here the flux that we are using it is of ZnCl2 zinc chloride or ammonium chloride. Okay, so we are using these kind of flux here. Why? Again, so that oxide layer cannot be formed. Again, so that oxide layer cannot be formed. Fine, so let us discuss about again the difference is here, my dear friend. Filler material, always and always there is a difference between a soldering and a brazing, that is in terms of a filler material. So let us talk about the filler material. So in soldering, filler, or again just a minute, filler materials is having melting temperature less than 427 degrees Celsius. Okay, so this is the nature, this is the first thing that is difference. So in the brazing, my filler material is having the more temperature than the like 427 degrees Celsius से ज्यादा होता था और base material के melting temperature से कम होता था. Fine, this thing we have seen, but in filler material just a reverse thing is there, that is 427 degrees Celsius से less होता है. Now what is the next point? Next point is that filler material is an alloy of lead and tin. Fine, so lead is also written as Pb and tin is also written as Sn. Fine, so this alloy, they are made of these alloys, that is made of lead and the tin, and this is known as solder. Okay, this is known as solder. We have seen these things, this is solder. Okay, now understand, filler material enters into the workpiece by capillary action. Now at this stage I am pretty much sure that you have understood the meaning of capillary action, the meaning of the capillary action. Okay, so here also in case of a brazing and in case of a soldering, the principle is same, that they are force, that these materials are like they are the filler material enters into the workpiece by the capillary action. So always and always remember, this is the most important point, capillary action. Fine, next point is there, we use the flux metals or the flux materials. Flux material is used such as zinc chloride, ZnCl2, and ammonium chloride. So basically always keep in mind that the flux material that we are using is having a property, that is chloride is always there, chloride will always be there. So always just have a keep in mind. If you cannot remember, that's not a issue. Just remember that chlorine Cl होता है flux material में हमारे soldering में. That would help you if any time like MCQ questions are asked, definitely you can answer it. So these are the flux material that are used. So why they are using it? Why we are using these flux material? So that oxide layer cannot form. Fine, cannot form. Now where we are using these things? Can you tell me where exactly we are using these things? Now before going into that, let me tell you one more thing. See, we can understand what we can understand here from this. So we have a lead and we have a tin. So if I would vary the percentage of the lead and the tin, we will be getting a different kind of solder. different kind of solder for a different applications. Understand. So we have a lead that is denoted by PB. We have a tin that is denoted by SN. Now understand. Now understand. Suppose if lead is 40%, and tin is 60%. Okay, this is the ratio in which they are added and the alloy is formed. So these kind of things are used for soft purposes, and hence you will get the soft solder. Fine. Now if you would vary the percentage like this, suppose if you have increased the 10% more, then definitely it is 50%, and this is also the 50%. If the ratio is same, then what you are getting the medium solder. Now we have seen in the electronic shop, they use a very different types of solder. Okay, they use a very different types of solder. In that solder, 60% lead is there and 40% tin is there, and that is known as electrician solder. Okay, this is known as electrician solder. Again, there is another one composition. If I am using a 70% lead and 30% tin, then these kind of soldering operations are used by the plumber, and hence it is known as plumber solder. So based on the applications, we have a very different names based on the applications. Okay, so these are the names. Fine. Now where exactly we are using these solder operations? This is like a very easy questions. Where exactly we are using it? We are using it for like for soldering the electricals and the electronic circuits, right? So what is the applications? What is the application? So application is, the first application is that it is used to design of electric and electronic circuit. So whenever we required to design an electric and electronic circuit, we use the soldering operation. Okay, so you have also used the breadboard, these things, these combinations are there, you have seen these things. Fine. So in these conditions you definitely use the soldering operation. Next is what? Fabrication of printed circuit boards, that is also known as PCBs. Okay, so in these conditions we are using the soldering operation. Okay, so now till now if you have any doubt, ask with me, otherwise I will go to the next topic. I cannot understand your question, Susant. Could you please again reframe this question? I cannot understand. See, brazing conditions means what? Brazing conditions means, understand it, there is a difference in the filler material. Always and always understand, brazing is similar to the welding operation. See, welding operation same होता है, welding जैसा welding में जैसा हम करते हैं वैसा ही होता है, but अंतर क्या होता है ना, suppose करें कि आप दो melting point वाले चीजों को जोड़ रहे हैं, है ना, this is having a different melting point, this is having a different melting point, this is of different material, this is of a different material. If these two materials are not same, properties are not same, very different materials we want to weld, in that condition we definitely use the brazing. And most important thing, brazing are used for a very low melting point material. See, very low melting point material, that it should be greater than 427 degrees Celsius. We are only and only talking about, see, the temperature range is very less, 427 degrees Celsius. If you could remember, in the welding operation, minimum 3000 minimum 3 to 4,000 degrees Celsius of temperature is formed. So you can very much easily say वेल्डिंग में बहुत ही ज्यादा टेम्परेचर होता है, उतना ज्यादा टेम्परेचर हमें नहीं चाहिए सर, वी डू नॉट वांट दैट काइंड ऑफ टेम्परेचर. सपोज इफ वी वांट दैट काइंड ऑफ टेम्परेचर, अगर मैं उतना टेम्परेचर दे दूं, दीज टू मटेरियल्स विल मेल्ट, ये दोनों मटेरियल ही मेल्ट कर जाएगा, तो वेल्डिंग क्या करूंगा, खाक, वेल्डिंग ही नहीं कर पाऊंगा मैं इसको. इसलिए सर मुझे जिस मटेरियल्स का बहुत ही लो वेल्डिंग मेल्टिंग पॉइंट होता है ना, उसमें हम इसको यूज कर लेते हैं. Technique is we can use any kind of technique, forward welding, backward welding, you can use any kind of technique is there. The thing is different is this filler metal. Okay, Sushant ji, have you understood these things? Okay, so let's move to our next topic. But before moving it, I again want to emphasize, this is due to the capillary action. Fine. What is the next? In soldering also this is due to the capillary action. Now there is a next welding process, that is known as braze welding. Now see, by listening this name you may be thinking, अरे सर आप तो भी ब्रेजिंग मुझे बताए हैं और अभी ब्रेज वेल्डिंग लिख रहे हैं, क्यों, क्या कोई डिफरेंस है क्या? हाँ सर, यस सर, देयर इज अ डिफरेंस. व्हाट इज द डिफरेंस? So in that brazing, the filler material was entering with help of the capillary action. The process was capillary action, but here they are entering by means of gravity force. Okay, so let me write it here. The first difference is that filler metal is an alloy of copper and tin, and this copper and tin is known as bronze. Fine, so this is the first difference. What is the second difference we have? Filler material or metal enters into the workpiece by means of gravity force. Okay, so gravity के कारण enter करता है, and that is the difference. Okay, so here the strength of joint is more, and we are using for only one applications, for joining of cutting tool tips. कटिंग टूल का जो टिप्स होता है ना, उनको ज्वाइन करने के लिए मैं इसको यूज करता हूं. सो व्हाट इज द मेन डिफरेंस दैट यू हैव टू अंडरस्टैंड, दैट हियर द डिफरेंस इज ऑफ द फिलर मेटल. So here the filler material is used as copper and tin, that is known as bronze. And other thing is that here, due to the gravity force, filler metals enters into the workpiece. But in case of a brazing, see, in the case of a brazing, we have seen this is the capillary action. The filler material enters into the workpiece by means of a capillary action. So this is the first difference. This is the most important difference between the braze welding and the brazing. Okay, so this is all about our welding techniques. Each and every welding techniques has been finished. Now we are going to start the welding defects. So if you have any kind of doubt throughout this, you can always ask with me. Otherwise I will proceed to our next topic, that is welding defects. Okay, that is welding defects. I'm waiting for your reply. If you have any kind of doubt, you can ask with me, and after that I will move on to our next topic, that is defects. Okay, that is the welding defects. welding defects. Okay, so now be happy, be happy. Why you have to be happy? Because this is going to be the last topic of your welding, and from today's onwards your welding will be finished. Your welding will be finished. Okay, so let's see. There is a first effects that is we are getting it, that is known as gas porosity. Gas porosity. See, can you see here, there is a gap, there is a like a hole is there, there is a hole. Can you see this hole? This hole is gas porosity. So what is basically happening in this? What is basically happening in this? If you could understand, suppose this is my, this is my plate. You can understand there is a cavity. So this is the weld, this is the weld bead, like this. Suppose this is my weld bead. Now what is happening in this weld bead? You will be getting the cavity like this. You will be getting a cavity like this. You will be getting the cavity like this. Holes are there, and this is the holes. These are the holes that is being produced when the atmospheric gases are absorbed. So what happens during the welding? Whatever the atmospheric gases are there, so atmospheric gases are absorbed in this thing, and what is happening? By absorbing the atmospheric gases in this liquid metal during the solidification process, it will form the gas porosity. Fine. So gas is entrapped, gas is entrapped in the liquid metal. Now this gas wants to escape out. Now this gas wants to escape out. So when it will be escaping out, it will form a cavity or a hole, that is known as gas porosity. Fine, that is known as gas porosity. So understand what is happening in this. By absorbing atmospheric gases in the liquid metal, during the solidification process, so during the solidification process, gas particles would be absorbed here, and during the solidification process, and form gas porosity. So this is a gas which is here. Now what you need to do, what you will be doing to remove these gas porosities? So what are the remedies? What are the remedies? The remedies is to provide sufficient amount of flux. Okay, we know that what is the use of the flux. So by using the flux, what is happening? It will protect the area, right? It will protect the area, oxide layer will not form. And we can also use by protect the liquid metal by providing shielding gas. Okay, so whenever you will be providing the shielding gas, definitely the welding that will be happening, these kind of defects will not be forming. Why? Because entire area will be shielded out. If you are using a flux, then always oxide layer will not form due to the flux, and definitely you will be get a very nice and neat and clean. And this atmospheric gases that earlier was entering into the liquid metal, now it will not enter. So I hope you understood these kind of defects. Okay, what is the main difference between soldering and the brazing? See, I have told you what is the difference. I have told you the difference. Difference is in terms of 427 डिग्री सेल्सियस से नीचे होता है, ठीक है, फिलर मटेरियल होता है, उसका टेम्परेचर क्या होता है? 427 डिग्री सेल्सियस से नीचे होता है, ठीक है। इसमें हम क्या यूज करते हैं, लीड एंड टीन यूज करते हैं एज अ सोल्डर, फाइन। इसमें हम फ्लक्स क्या यूज करते हैं, जिंक क्लोराइड यूज करते हैं, अमोनियम क्लोराइड यूज करते हैं। और ब्रेजिंग में हम क्या करते हैं, ब्रेजिंग में टेम्परेचर ग्रेटर देन 427 डिग्री सेल्सियस होता है। कॉपर जिंक यूज करते हैं, सिल्वर अल्यूमिनियम यूज करते हैं, फ्लक्स क्या करते हैं, बोरैक्स यूज करते हैं। दिस इज द बेसिक डिफरेंस, this is all about the difference. And we have also seen the capillary actions, है ना। So this is the similarity in the capillary actions, what exactly is happening throughout the soldering and the brazing things, right? We have seen these things. Okay. Okay, I okay, don't worry, at the end of the lecture I will share in this comment box only, I will share the whole playlist, don't worry, don't worry. Okay, I will share it. Shivam Pandey ji, stick with me. At the end of the lecture I will share it. Next what is the next thing? Next defect is slag inclusion. Now see this welding technique. Now see this welding technique. This is a plate. In this plate we are having the welding, and see, this is what, this is the slag. This is the slag that is inside the weld. So these are the slags. These are the slags. So what is happening, my dear friend? Suppose, see, we have seen that in when I was teaching the welding in very like great details, then I have told you that what happens, this slag is formed, and these slags are like very much lighter materials, and they come in the top. So when they are coming in the top of the weld bead, so they are advantageous for us. But what happens, suppose if suppose this is the slag that is coming on the top. Now after the first pass of the welding, you have got the slag here. Now again, if you are doing the multiple pass, again the multiple pass is there. So suppose if the multiple pass would be there, then definitely metal will be deposited here. So again the metal will be deposited here, and above the material again the slag will be deposited. So what we can understand, this slag is entrapped here, and slag inclusions may form. So this is one of the reason why which we are getting the slag inclusions. So what is happening, so due to the lack of proper like heat input is less, or improper positioning of the welding torch is there, these kind of problem due to or we are giving the multi-pass, or we are giving the multi-pass weldings are there. So in these kind of things we are getting the slag inclusion. Okay, so let me write it here, my dear friend. So due to lack of heat input, improper positioning of welding torch, so due to this, what is happening, or you are giving a multi-pass welding is there, if you are conducting a multi-pass welding. So due to this, what is happening, slag can be included in the weld joint. So what is the remedies? What is the remedies? So the remedy is that to provide sufficient amount of heat input, because see, we have seen that lack of heat input is there. So definitely lack है, कम हो रहा है ना, अरे भैया ज्यादा दे दो, कम है ज्यादा दे दो, provide sufficient amount of heat input. And what is happening, improper positioning of welding torch, कोई बाहर का चीज घुस जा रहा है, slag inclusions हो रहा है, oxide layer में भी forming. चलो उसको एक काम करते हैं, what we are doing it, we protect the liquid metal by using inert gas. So by using the inert gas means what, shielding gases. Now understand, अरे सर एक चीज तो आप अपने दिमाग में बैठा ही लीजिए, अरे हर चीज का मैक्सिमम डिफेक्ट्स का इलाज क्या है पता है, मैक्सिमम डिफेक्ट्स का इलाज है सर उसको शील्डिंग गैस दे दीजिए, शील्डिंग गैस दे दीजिएगा, बाहर का एटमॉस्फेयर नहीं जाएगा, ऑक्साइड लेयर फॉर्म नहीं करेगा, आपका कहीं पे इंक्लूड नहीं होगा. ये तो बहुत ही कॉमन रेमेडीज है दैट यू कैन डू इट. बहुत सारे रेमेडीज में तो आप फ्लक्स भी डाल देंगे, फ्लक्स डाल दीजिए, इनर्ट गैस डाल दीजिए. दीज टू आर कॉमन थिंग बाय विच यू विल गेट अ वेरी फाइन वेल्डिंग. Okay, so this was all about the slag inclusion. Let's talk about the weld spatter. What is the weld spatter? Remember, I don't know how many of you have watched my video of arc blow. In that arc blow, I have told you that due to the arc blowing of the arc, what is happening? This is a workpiece, so this is the electrode. So what happen will blowing outside, so it will form some kind of spatter, है ना, चिट चिट करके ऐसे करके छोटा 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 spatter form करता है. And this is all about the spatter. See, these all are the spatters. These all are the spatter. Can you see it? Small droplets are there. These all small droplets are known as weld spatter. ठीक है सर, इसको कहते हैं हम weld spatter. चलिए समझते हैं क्यों weld spatter हो रहा है. Why? Due to splashing of the liquid metal after solidification on the base material, rough surfaces can be produced, known as spatter. So these are the very rough surfaces that you can understand. These all are the rough surfaces that is known as. What is the remedies? So remedy is that provide, see, कितने लोगों ने आर्क ब्लो किया था अटेंड? अगर आप लोग आर्क ब्लो के लेक्चर्स को अटेंड किए होंगे ना, तो इन दैट लेक्चर आई हैव टोल्ड यू व्हाई देयर इज अ आर्क ब्लो, व्हाई देयर इज अ आर्क ब्लो. सो टू गेट द आर्क ब्लो, reduce the arc blow concentration, what we are using it, we are using the flux. Number one, we are using the flux. So always remember, so provide more amount of heat input, sufficient amount of heat input. So provide sufficient amount of heat input and reduce the arc blow. So reduce the arc blow, and you can also use the flux, because when you will be using the flux, automatically arc blow will be reduced. So this is the most different type of a defect that we are getting in the welding. Okay, let us understand the next type of welding, that is welding defect, that is lack of fusion and penetration. Lack of fusion and penetration. So what is happening in this lack of fusion and penetration? Understand. So this is the like this, suppose this is the metal. So this is the material that you want to weld it, and what is happening, you are getting these kind of welding like this. Okay, understand. Suppose these kind of weld BD that you are getting. So suppose these kind of weld BD that you are getting, so this is due to the fusion is not happening in a proper way. And see, this weld bead is not properly penetrating in this workpiece, right? So these kind of defect give me the rise of lack of fusion and penetration. So why this is happening? Due to lack of heat input. Suppose that if you haven't given the proper amount of heat input in here, in this supply, in this case, so if heat input is not there properly, the weld bead will not form properly. Whatever the filler material that you are giving properly, they will not melt and they will not go inside it, and definitely you will get a defect. Okay, what is the next reason that you have seen? That filler material or filler material or metal is not penetrated with base metal properly. So these are the problems. So what we can do it to improve it? So provide heat input is less, so provide heat input more. Fine. So very easy things are there. Provide sufficient amount of, okay. Now see, sometimes what happens, देखिए, अगर मैं वेल्डिंग स्पीड जो वेल्ड कर रहा हूं ना, if I will do the welding speed like very fast, if I would do the welding very fast, then what will happen, I will not give time to get my weld proper, weld will not get proper in a proper fashion, welding will not be in a proper fashion. And when the welding speed is very high, the weld deposition, whatever the metal is getting deposited in the cavities, that will not deposited properly, and hence you will definitely get these kind of situations due to the fusion and penetration problem will be there. So what you can do it, you can provide sufficient amount of heat input. Oh, sorry. You can always provide the sufficient amount of heat input. These things I have already told you. What you can do it, I have explained you. What you can do it, you can welding speed should be optimum. Welding speed should be optimum. Fine. So this is all about this welding defect. Let us talk about the another welding defect, since we have a lot less time, so I'm just moving it very fast. Next is weld cracks. Now what is this weld crack? You have already seen this weld crack is what. Suppose you have a welding like this. Suppose this is the weld bead. Fine, suppose you have a weld bead. So in this weld bead, you will find a cracks like this. Suppose there is a crack like this. These are the cracks. Suppose these are the cracks like here. Suppose there is a crack. These are the cracks on the weld bead. So what is happening here? So in this case, due to नॉन यूनिफॉर्म कूलिंग, है ना, कहीं पर कम कहीं पर गर्म है, कहीं पर ज्यादा है. सपोज अगर आप वेल्ड कर रहे हैं, व्हेन यू आर डूइंग अ वेल्डिंग, सपोज एट दिस पॉइंट more heat is there, more heat is concentrated, at this point less heat is concentration, so there is a difference in a heat. So what is happening, if there is a non-uniform cooling in this case, so at this case what is happening, whenever there is a non-uniform cooling, internal stresses can be developed in this case. So if internal stresses will be developed, that internal stress will get inside it, so that is a residual stress that will form. Now when this stress will try to relieve it, or will try to get out, so when this stress will be relieved, then it will form a tear, it will produce a crack in the weld bead. Fine, in the weld bead. So due to the non-uniform cooling, internal stresses can be developed in the weld. Fine. Now see, this is the first point that we have seen. What is the second point? If the stresses will be more than the strength of the base material, cracks will be formed. Fine. So what is the remedies, what you can do it? So देखिए, अगर आपके पास मेटल है, अगर आप उस now this whole metallic arrangement, whatever the weld you want to do the welding, so the workpiece is at a lower temperature, right or wrong? The workpiece is at a lower temperature, so it is at a room temperature. Now you have generated an arc, and when you are generating the arc, you are doing the welding. So what is happening, my dear friend? Understand. So now you have the object, that is the workpiece. So workpiece is at a room temperature, that is maybe around 25 to 30 or 40 degrees Celsius, somewhat like that. But now at a random, what you are doing it, you are generating an arc and doing a welding. So this is forming these kind of problem. पहले ठंडा था, अब गर्म, ठंडा गर्म, है ना. तो क्या करना चाहिए? फॉर दिस मोस्ट इंपॉर्टेंट थिंग इज देयर, प्रोवाइड pre-heating and post-heating. So preheating and post heating of the workpiece will definitely help to not form this internal stresses, and when this internal stresses will not form, my dear friend, okay. Now one more thing I have told you in a very starting thing, that gas porosity is there, right? So what is happening in this gas porosity? Basically, the atmospheric gases are uh, in that part, right? Now understand there is one more concept that I should give to you, that if hydrogen gas will be trapped will be trapped inside the liquid metal, if 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 hydrogen gas will be trapped inside the liquid metal, like this, suppose in this we have seen the atmospheric gases are there. So if anyhow this hydrogen gas will be trapped inside the liquid metal, so what will happening, this will form a crack, this will form a crack. What's now, just now we have seen the crack concept, so this will form a crack, and due to this crack a defect will be formed, a defect will be formed, that is known as hydrogen hydrogen embrittlement embrittlement brittlement. So there is a defect that is known as hydrogen embrittlement. So always remember these things. These things are very much important. Okay, so hydrogen embrittlement. So this is basically related with the crack also, crack concept also, and the porosity concept also. So that's why I have used these two slides to correlate these things. And there is another thing that is formed, hydrogen embrittlement. Fine. So this is the one defect. Let's move to our next defect, that is known as weld decay. Weld decay. This is like last. Don't worry, I will just wrap up these things very early. So suppose what is happening, weld decay में क्या होता है, you will get your joint will be somewhat like that. Okay, your welding would be somewhat like that. So this is the metal and this is the weld bead, like this. Suppose this is the weld bead. Fine, this is the weld bead. So near about the weld bead, what you can understand, these things are what? These things are decay. These are known as decay. So what is happening, suppose in case of a stainless steel, suppose in case, basically these things are watched seen in case of a stainless steel. So what is happening in case of a stainless steel, due to the fast rate of cooling, what is happening, whatever the chromium present in that, suppose, see, when you are doing the welding, so this would be the heat affected zone. Near about the part would be the heat affected zone. So what is happening, the heat affected zone, that is converted, that chromium is converted into chromium carbide. When you are doing the fast rate of cooling is there, whenever the fast rate of cooling is there, this chromium, due to this, what is happening, from here, from this part, chromium is absent. Okay, so chromium is the absent. So when chromium is absent from here, there is a chance of corrosion. So this is basically in case of a stainless steel. So in case of a stainless steel, chromium is present at the heat affected zone. And what is happening, let me write it here also. What is happening, due to fast cooling, what is happening, whatever the chromium is present here, that is converted into the chromium carbide, and the pure chromium is absent. Now this metal is exposed to the atmosphere, and there is a possibility of corrosion that can happen here, and this defect is known as weld decay. This defect is known as weld decay. Okay. Now what you can do it, remedies is again same thing. What is the remedy? Temperature uniform nahi tha. Definitely if temperature would have been uniform, then what if temperature would have been uniform, then definitely fast rate of cooling nahi hota na. So what we can do it, we can provide preheating and post heating. Now let me explain some more welding technique. These are very short welding technique. This is the underfilling. What is the underfilling? What is this underfilling? Understand, there is another defect that is known as underfilling. Understand, see, this is a weld bead, this is a weld bead, and here is the gap, here is a gap. If I would zoom it this part here, see, there is a gap, there is a gap. In this gap, what is happening? When joint is not filled with the proper amount of weld metal, see, the proper amount of weld metal is not here in this joint, that is known as underfilling. Fine, that is known as underfilling. So let me write it here. When filled with proper amount of weld metal, then this is forming the underfilling. Next is what? Undercut. What is the meaning of undercut? See what is the meaning of undercut. If you could see here what is happening, so this was the line of the metal, like you can see here, they have reached to the base metal also, they have reached to the base metal also. So what we can see here, it results on melting away. So here what we can say here, base metal is melted away, right? So this is what is the problem in the undercut. Undercut मतलब क्या? कट जाता है, बेस मेटल का कुछ पार्ट को मेल्ट करके हमारा फिलर मटेरियल या भी जो हमारा वेल्ड बीड बनता है वो उसके जगह को ले लेता है. दैट इज नोन एज अंडरकट. सो इट रिजल्ट्स फ्रॉम melting away from base metal and consequent generation of groove. So here maybe a groove is present, groove shape हो जाता है, या देख रहे हैं कुछ नॉच टाइप का फॉर्म कर रहा है, groove in shape of notch. This is known as undercut. This is the last defect that I am going to teach you of this entire sessions. So be happy. What is the meaning of the overlap? So you cannot understand from this figure also. See what is the meaning of overlap. Suppose if you have done the welding like this. Suppose you have done the welding like this. Fine. So this is a welding. Just a minute. Suppose this is a welding like this. Suppose in this fashion the welding bead is formed. Now this is the first pass. Now again what you are doing? You are doing again the welding like this. This is second pass. Again what you are doing? You are again welding like this. So what is happening in this case? Suppose if you are welding like this. So let me write it here. Surface discontinuity usually caused. So there is a surface discontinuity here, and this is usually caused by poor welding practices. किसी नौसिखिए से अगर मैं वेल्डिंग कराता हूं ना, तो वो नौसिखिया इस तरह का गलती कर सकता है. सो 3-4 वेल्डिंग पासेस हो जाएंगे तो कुछ थिक, इस तरह का थिक आपको मिलेगा. एंड यू कैन अंडरस्टैंड. सी द ग्रूव इज लाइक दिस इज लाइक नैरो इन दिस सेक्शन नैरो है, यहाँ पर थोड़ा सा बड़ा हो गया. सी the weld bead is like more in this case. Here again it is narrow, here again it is thicker, here again it is thicker, again it is here more thicker like this, more thicker. Now again this is narrow like this, narrow. So you can understand there is a surface discontinuity. This is known as overlap. And by material. So these are the causes due to which we are doing the we are getting the overlap kind of defect. So this is all about from my part for the today's session, my dear friends. If you have any kind of doubt, you can give me the message, and I would really happy to solve your problems. And if you have really enjoyed my throughout this video, do like this video as well as share this video in your friend circle, in your peers, so that you will be getting benefited, your friends will be benefited, your everyone will be benefited. So what is that? It is a win-win solution. Help each other and definitely you would succeed. So if anyone is wanting like to purchase the plus subscription, use my code SIRVK. You will be getting a 10% off, as well as I will provide a personal mentorship to you also. So you can always use my code SIRVK. If you have any doubt, tell me. What is the main difference soldering and brazing? I have told you. We can use 5-piece rod place 4-piece. What is the process and technique? I could not understand your question. Sir, playlist नहीं मिल रहा है, please. Okay, okay, I'm sharing the playlist. If you have any doubt, then tell me, and please reframe the question once again so that I can understand you. So you can find the playlist. You can find the playlist. So I've shared the playlist here. Have you got these playlist? Okay, so there is a problem in the sharing, I think. Uh, you can search about it. Manufacturing engineering GATE 2021. See here. You can search here. Manufacturing engineering GATE 2021. By this name, I have created a playlist. You can search my name, and you will get the three. You will get actually the two playlists. One playlist will have the metal cutting, and the another playlist will have the welding and casting. So any doubt throughout it, please tell me if you have any kind of doubt. From tomorrow onwards, I'm going to start the forming process. I'm going to start the forming process. Okay, so I assume I'm ending this session here only. Thank you so much for your active participation and making this session to be very much interactive. So I'm ending this session. Thank you. Okay, thank you so much.